Hi, welcome. Today's all about the app system. But first of all, why did we even build it? So you have to see this. We want to support the merchant throughout all their journey, from their humble beginnings with a small store to quite a large, successful online presence. So to do that, we started building a Shopware cloud solution. And this cloud solution has one drawback, and that is that because everybody shares the same code base, you can no longer inject third-party code into this code base. It becomes too much of a risk because if this third-party code in any way inhibits a store, breaks it, or maybe even opens up security problems, then these problems affect all stores hosted in this cloud environment. So we can no longer provide direct access to the source code with cloud shops. And to still provide the extensibility that you've come to know and love about Shopware, we had no other choice but to build another extension system, in this case the app system. And even though this system came from the cloud, it is off the cloud, it is not only for it. The app system works just as well on-prem as it does on the cloud. Again, we want to cover the whole merchant's journey. So our app system, and this was a design requirement from the start, had to be able to run in cloud shops as well as in on-prem shops. But how did we achieve that? We achieved that by moving the interface. Normally with a plugin, the interface is your source code. Just as the name implies, stuff like abstract classes and interfaces in PHP. But with the app system, we took this interface, this implicit interface in a way, and moved it out so that the new interface is the API. If you know a bit about microservices, this might now seem to sound familiar. In a way, this is splitting a monolith into little services, allowing everyone to focus on their domain. So every one of these little services, be it us with our cart, product management and CMS functionality, to your app with their domain, now they all have the ability to concentrate fully on that domain. This is what is meant by reducing coupling. You no longer have to depend on the details of what our source code does in the Shopware core. You can now concern yourself more with the API, which is a lot harder to break and to change accidentally through changes to the source code. And as you can see here, I've brought with me a little example on how this works. On the left side, you see a filter the new way, or build the new way through the app system. Although, again, new way is kind of a misnomer here because this already worked. This is just the admin API. And as you can see here left, we have a filter that is basically the same as the criteria that is built on the right side. So the right side is how you would have built it previously. You have or you instantiate a criteria object, add filters to it and associations. And just the same way, you can do that with a criteria JSON object that you can give to the search endpoint of our own API. And that is the gist of it already. If you want to interact with the shop, you can use the same API as the administration, which means that almost everything a user can do can be done by an app. But for you to use the API, you need to access it. So let's have a look at how this access works. Once an app gets installed, we have a process we call a handshake. And this handshake is how your app receives the authorization to use the admin API of the shop that bought the app. So as you can see, first of all, when the app is installed, Shopware fires a registration request to your app backend server. This request contains a signed secret. So Shopware goes optionally, it is not necessary, but optionally, talks to Shopware server and gets the authorization that the shop has the license to use the app. Then, with this signed license, it again requests a registration from the app backend server. The app backend server can then register the shop, verify the request and the license, and then return a response with a further step and a secret, so that the that the Shopware instance from that point on can authenticate itself against the app. So you always know from which Shopware instance requests come, and that they are necessarily from that instance. And then you will get a confirmation request from the Shopware instance, which contains the credentials you need to access the admin API. Again, you can also add some add some permissions with auto-generated role, so that the app user, the merchant, will know what kind of data your app can access, providing safety on both sides. But the good thing is, even though it sounds a bit complicated, is you don't even really have to implement this yourself. We provide SDKs in several programming languages. For example, we have a SDK or a template in PHP, we have one in Go, and we have a template in JavaScript that is able to both work on Node backends as well as in plain JavaScript ES 2000, I believe 2017 environments, like for example Cloudflare workers. So now that we know how we can affect the shop, the data itself, what happens when something in the shop changes? For that, we have used a, by now I believe, pretty well-known system called webhooks. A webhook is a bit like a subscriber, if you know your object-oriented patterns. Your app has a file called a manifest, and in this manifest, it describes the interface it has with the shop. So in this manifest, there is a section especially for webhooks, and a webhook consists of an event you want to be notified about and a URL to which to dispatch this event, again as the body of a post request. And those events are just the events that run through the normal Symfony event bus. So as long as an event is exposed through the webhook system, you can subscribe to it with your app. And even if this event isn't currently exposed, exposing it is just a matter of a single line. So if there are some features you need, feel free to open up a merge request. It is not a lot of work. So let's talk a bit about the process. So let's say we have a webhook that, for example, subscribes to the creation of an order. So a user clicks through the storefront, creates an order. The order created event goes through the Symfony message bus. Then our general app system webhook subscriber will notice that. It will first of all handle the request of the user so that the performance of the shop still remains the same, while at the same time making a notice to dispatch the event information to your app server. So the event gets serialized into a JSON object, and this JSON object gets then dispatched to your server, where with your own custom backend logic, you can pick apart this payload, look at its contents, and then react to it, maybe saving some data on your end, or manipulating the order through API calls, or manipulating different other entities, again, all through the API. So let's look at an example of that. This is the example payload when a shop deletes a product. It is split first of all in three major parts. It's a data part, a source part, and a timestamp. And quite sensibly will work from bottom up. First of all, in the lowest rung, there is the timestamp. This again is just a Unix timestamp, an integer that shows you when this event was actually fired. Then you have the source key. The object stored under the source key contains all metadata about the Shopware instance that provided you with this element. It contains stuff like the URL, what version the app was, what version of the app is installed, and the shop ID. And with the shop ID and the signature that is generated for this payload, you can be certain that this payload really comes from the shop it says it came from. And the word payload brings us directly to our last key. It's called data. Data contains all the serialized or everything of the serialized event. In our case, a payload, which is the event data, so what entity it was performed on, the operation, and the primary key, and also the event name, in this case product written. And this is basically all you need to know about webhooks. And should you miss some data, for example, in this example, maybe the primary key is not enough, you can still interact with the Shopware instances API from within your handling of the webhook. You don't have to think too much about latency and stuff, because the request to your system is already being done asynchronously with the request that happened on the Shopware instance. But what about things the user does? So the merchant in the administration. There are two things that, there are two things how the merchant can interact with the administration through the app system. The first one are action buttons. As you can see here, action buttons are buttons that can be added to any entity detail page or listing page in the administration. Once such an action button is defined, it pops up under the three dots out there, above the entity and can be triggered from therein. Once an action button is triggered, it will then either send on a detail page the entity details to your app server, or on a listing page all selected entities. But once you have received such a request, the question is, how do you handle the feedback? So how does the user know something happened? There are several ways, and the first of them is the app server can respond with a command to reload the administration. So if some important data changed, you can just say, hey, please reload me, and after the action button was triggered, you will have, or the administration will get reloaded. The next is, you can notify the user. So you can define a custom message to be delivered to the user, as well as a headline and of course a style. So you can inform the user not only about errors, but also about success messages. And last but not least, you can open up a custom modal, like in this case. The custom modal works such that once an action button has been clicked, you respond, or your app server responds with another URL and the command to open it in an iframe. So the modal will open, again with an iframe inside it, and this iframe will provide will provide the URL with an extra signature as a query parameter, so that this signature is already enough to authenticate the user and show some data that you then output onto the modal to provide custom UI for your user. And speaking of iframes, iframes are also the second way you can extend the administration UI. You can define a custom module, which then will be just as visible as our current modules, like the CMS or the product pages. And in this module, you again have the ability to open up an iframe with a custom UI, so that you can manage your UI just the way you want to. And this means that it's your freedom to choose any framework. For one thing, you can choose any kind of backend framework you want. And not just frameworks like Symfony or Laravel, but you can decide to just use a completely different language. And on the JavaScript side, the inclusion of iframes also mean that you can use any kind of JavaScript framework or none at all to render your administration interface. This is all fine and dandy, but what about the storefront? You have to customize this one as well. I've got good news for you, because the app system allows you to distribute template styles and JavaScript just like plugins did over the app binary, the zip file. The zip file contains a resources folder just the same way that plugins might provide one, and as such allow you to store in this resources folder stuff like template styles, icons, JavaScript, so you can use them to customize the storefront. The theme system works more or less one-on-one with the app system as it does with the plugin system. And another way to configure apps or to extend shops with apps is through the custom config and fields. As you might know, plugins are able to provide a config XML that auto-generates some configuration fields and a configuration page, and allows the plugin to store globally some configuration for its own namespace. And with the app system, you can also define a config XML and just read from it in the storefront. As such, allowing already quite a wide variety of apps without any need for a backend server, because it's just the JavaScript in the storefront interacting with the config values specified through the config XML. And also you can add custom fields to entities through your app and custom field sets, as such providing a way for users to define some extra data that can be added to some entities like products, for example, but also as a way for your app backend to add additional data to some entities that can then be shown through the storefront. So as an example of an app that just needs the configuration, the global configuration, and a storefront edition, in this case JavaScript, without any need of a backend, is our Snowflake plugin that you can already get in the store. So the configuration that is configured through the config XML, and boy did I say config a lot, is used to control how the snowflakes look and how they behave, all through the onboard features of Shopware itself. But snowflakes are not the only thing you need in your storefront. Another important thing are payments. And the app system does provide you with the ability to add new payment methods, either synchronously or asynchronously, and all the kind of callbacks you need for that you can then just implement in your app and become a connector, for example, to a payment processor. So to sum it all up, the general advantages for both the developers and the merchants are that apps do happen on the cloud as well as on-premise. Again, allowing apps to be a help to merchants all across the journey. The other thing is the app system always keeps apps up to date. So the apps get automatically updated, meaning that the developer does not have to think about maybe dozens of versions that are online somewhere used by some customer, while the merchants themselves can be sure that they always have the newest version for their app. The merchants in particular profit also of the sense of security they get from knowing precisely where the data is going, whereas a plugin can access any data anywhere, anytime that is stored on the server with a shop. The app system provides a way to define roles for an app, so that just for example, like you would on an Android app or an iOS app, the merchant is asked to accept the data that is read by the app. And as such, providing a bit of safety with the whole data flow. And the other thing is, apps can not interfere as much with the shop's performance as, for example, plugins can do, because apps always run asynchronously, webhooks and the like. So the normal flow of a customer through the storefront is not changed at all by apps. And there are also some advantages for the developers. Again, this is the point we had about separating the domains. The clearer interface, the loose coupling between your app and the Shopware instance itself does mean that the app can concentrate more on its domain, on what it wants to achieve. It does not have to understand in as much detail how Shopware does its thing, so it can hook into the code and then try and change it in the way that the app wants to do things. Now we have two clearly separated domains with an interface between them that is negotiated regardless of any source code, which also brings us to another advantage, and this is that when developing a plugin, you build implicit dependencies all across the code, because you are not only depending on interfaces, but you may be also depending on the order that certain functions in an interface may be called, or that in general certain events may be thrown. And as you might know, these are side effects. You cannot specify stuff like protocols throughout an interface in PHP easily, and in some parts, not at all. And this means that unintentional breaks may happen in minor versions. We do not change the actual signature of an interface, but we may accidentally or fully knowing change the way things are called, just the order that things are called. Or we may be trying to open up a refactoring path by changing the underlying implementation. And maybe your code is dependent on that. Or maybe what you wanted to achieve is not possible through the standard interfaces, and now your plugin is broken because we changed something which we thought you didn't use, basically. With apps, there is only one way to properly interact with the data management or Shopware, and that is through the API. And we only break the API to major versions, thus allowing you to have one point at which to make the decision how you want to interact with the shop. When you receive a request to a shop, you will be notified what version of Shopware it's using, and as such can make switches on what kind of code you want to use to interact with the shop. But for sure, we also know that a new extension system brings new challenges. For example, API breaks. Sure, I just said that API breaks do happen less frequently, but they still happen, and we no longer have separately versioned APIs. Our APIs now are wholly dependent on the major version of Shopware, and so as I just said, your app should be aware that it may be used on several different versions of Shopware, and as such contain a central switch to change its behavior, to change how it interacts with Shopware dependent on its version. But we believe this is handled by a bit of software engineering, because you have to think about the shop no longer as the, in a way, driving system of your logic, but more of a kind of repository that is used by your service to achieve the wanted outcome. Another thing is, we know that you as plugin developers until now did not have to think too much about hosting. But for that, we try and provide tutorials and helpful guides to get you to, or to give you an overview about all the different ways that you can host stuff. And also we have partnered up with platform.sh to provide you with a trusted partner that knows how to run environments, how to run deployments and stuff like that. Mostly automatic, and just focus on the source code you're writing and the business logic you want to produce. And speaking of hosting, we of course know that this is now involved in a bit more cost, because for a plugin, once you've wrote it, you didn't have to pay for it to run. This is all part of the general shift from a, code provider, from a product provider to a service provider. You're now providing a service. But as with any service, we believe that the key in cost management is a mixed calculation, just we do with our cloud service. Because consider this. Sure, with any service, there may be outliers that really intensely use your service, way more than it is covered by their monthly subscription cost. But these are, as I said, outliers. Most people are actually using your service below average. They are not using as many resources as they would normally pay for. And this allows you to provide a mixed calculation where the general people that use your service and those that barely use your service subsidize the heavy users and do this in a way that you still run a profit. And last but not least, we do know that the app system is lacking some features that are needed to fully customize Shopware the same way that it could have been done with a plugin system. But consider this. Sure, the app system is already a year old, but the plugin system itself has been a part of Shopware since Shopware 3, I believe, or 4. And as such, it had way more time to mature. And we are constantly developing the app system and trying to listen to your feedback and open up new ways that apps allow you to customize Shopware just the way that you need to support the merchants. And speaking of future development, what's next for the app system? One thing that we're very keen to introduce is private apps. Private apps is what we call the feature that allows you to upload an app binary, so a zip with a manifest and a resources folder, right into your cloud shop without going through the Shopware store. This allows two things. One, it allows agencies to make small customization to Shopware shops on the cloud, but it is also a big improvement for all the app developers out there that want to get started, because private apps means that they no longer need to host their own Shopware instance and work with it, but instead they can just let us host the Shopware instance on the cloud, and then they can develop against this and just upload their work in progress app as a private app. Oh, sorry, skipped one. The next thing is the CMS elements. Right now it is possible to define CMS blocks through apps, but we want apps to be able to fully utilize our CMS, and as such we're working on providing CMS elements through our app system. Another thing is the dataset manager. We know that storing data in separate places, so part of the data stored in the Shopware instance, part of the data stored in your app database, is for some things not a good solution. It splits your data modeling up into pieces, and maybe you don't even want to touch some data permanently. And as such, we want to provide you with a way to define new entities in an app, so that you can realize your own data structures and data modeling that is then saved to the database of the Shopware instance, and can as such also take into account constraints like foreign keys and stuff like that. And again, you are what makes Shopware so great. You are the people that cover our gaps. So we also want your ideas. We want to talk to you. We want to know where the stumbling blocks were for you, where some things are that still block you developing the feature you want as an app. And we will listen to it. And if you're so inclined, feel free to open up a merge request. Those are always very welcome, but just talking to us about what you like, what you don't like, and how we could improve is already very valuable for us. So with that, I thank you for listening to me rambling for a few minutes. See you around.